Hey, welcome to Skype with Scientist Live. Today we are talking about mountains and rocks with Stacy Phillips. We are excited. Stacy was on our No Time Like the Presentation show and was amazing, and so we're really excited to have her today. Housekeeping, next week we are talking about elephants on Tuesday and something on Friday. Bugs. Friday the 29th at 1 p.m. We are trying to have all of our events now at 1 p.m. so it's kind of like more predictable, but Tuesday is at noon because our scientist was not available at 1. So Tuesday, elephants, Friday, bugs, and Gwen is who is speaking on Friday, is a really, really amazing bug communicator, and I honestly think that she's going to have actual bugs with her, so that's going to be pretty exciting. Also, all of June, we're hosting for the first 3 weeks, all queer scientists, so it's going to be really awesome. We're partnering up with a group called Noble Step. They are a advocacy group and professional society for queer scientists, and so we're really excited about that. And we're also going to be talking about a lot of cool stuff. Like we have a paleontologist who works on triceratops, and we're going to be talking to somebody who studies hagfish slime. We've got a bunch of people who do a bunch of different aspects of space things. So one person studies collisions in space and how that ends up looking a lot like fireworks. And overall, it's just going to be like a wild, awesome month. And then the fourth week of June is Cephalopod Week, which is obviously my favorite month or week of the year because we focus all on cephalopods. It's something that Science Friday started a number of years ago and has grown, and so we're really excited about that. Other than that, if you can support our program, please do. You can support us at patreon.com/SkypeAScientist and give a monthly donation. Even like $1, $5 a month really adds up when many people band together. And most of our donors that keep this program going are only giving us a couple bucks a month. But it's hugely helpful when everyone bands together. In addition to that, you can also make one-time donations at paypal.me/SkypeAScientist. But that's enough housekeeping for me. Let's talk about mountains. So yeah, Stacy, do you want to introduce yourself? Say who you are, what you do, and why you like it?
All right, thanks for that intro, Sarah. Hi everyone, my name's Stacy. I've got a little presentation that I thought I would walk people through, if that's okay. Let's see if I can get that, and everyone can hear me okay?
Yes.
Right.
If you are a person who needs Erin, make sure that you click the top right after Stacy shares her screen. There will be like 2 little rectangles on top of each other. Click that, and then you'll see everybody.
Awesome. Good point. Right. Let's have a go with this. Okay, does that look like a PowerPoint presentation?
Totally.
Brilliant. Okay, so yeah, my name's Stacy and I'm a geologist, and I'm really interested in how you make mountains. So mountains are the most spectacular of geological formations in my eyes. I wanted to give you a little bit of an overview about how I go about looking at mountains and what I've kind of done in my science career so far. These are my my Twitter handle. If anyone wants to get hold of me, hit me up on that, not a problem. So yeah, I'm currently a PhD student, but I started my geology career doing my bachelor's at the University of St Andrews, which is in Scotland. So I'm originally from the northwest of England, which is where I am at the moment. But I went to the University of St Andrews to go and learn about rocks, and Scotland is a phenomenal country and great for rocks, great for all sorts of things. And I love my time there, and I got to see so many rocks all over Scotland. This is a picture of me on the far west coast of Scotland on a beach that to me could easily be in the Caribbean. And I absolutely loved spending 4 years there. And then I was like, right, I really like geology. I'm going to continue to study it. And then decided to move to Memorial University, which is in Newfoundland in Canada. Very similar rocks to the rocks of Scotland, other side of the ocean. And I was in Newfoundland, but I was actually working on rocks in the Mojave Desert in California. So this is me in the Mojave Desert. And again, just really loved kind of doing research and getting stuck into trying to figure out what these rocks could tell me about the Earth and the Earth's history, and really enjoyed it. And then was lucky enough to get a PhD position, this time back in England at a place called the Open University, which is in a place called Milton Keynes that's not too far away from London. And that's where I got the phenomenal opportunity to do the PhD that I'm just coming to the end of 4 years of having done. I'm writing up my thesis now. Its hand-in is imminent. So it's a happy but stressful time for me at the moment. Yeah. And so I'll run you through kind of a bit of the PhD work that I've been doing. And yeah. And one of the things that's driven me through all of my kind of geological career is this one thing, and I have to confess it to you now. I think that rocks are fabulous, okay? Lots of people do not share this view with me. That is fine, but I am here to tell you 3 reasons why rocks are fabulous. So rocks are fabulous, first of all, because they're super important to us. So anything that you can't grow, you have to dig up out of the ground. And our entire modern society runs on rocks and metals and minerals that we dig up out of the ground. So the computers that you're using right now, your mobile phones, there's loads of gold in mobile phones. And to get that gold out of the earth, you needed a geologist to know where the gold was. And yeah, so rocks are super important. Our modern society could not work without them. The other cool thing about rocks, the other reason why rocks are fabulous is because they've allowed me to travel the world. As I mentioned, I've studied in Scotland, in Canada, in England. The pictures that are on the screen here are I've got from Spain, from where else I've been, from California, from Greece, from Italy, all over the world. Geology is a very hands-on subject, and we like getting into the field and looking at rocks up close. And that's one of my favorite parts of studying geology, is that we get to do that. And rocks have enabled me to travel to some wonderful places. And then my third point about why rocks are fabulous is because rocks can tell us stories. Rocks tell us stories about the history of our Earth, what's happened over the last 4.5 billion years that our Earth has been around. You have to learn how to read them. But they can tell you some wonderful, wonderful stories, and I'll hopefully share some of them with you today during this little presentation. And as I mentioned, I'm a geologist who's really interested in mountains, these big towering blocks of rock that are, for some reason, they've risen up above all the earth around them. And you get these fabulous peaks here. This is a photo that I've taken. And while I'm talking, I'm not going to tell you where this is, but I want you to think about where in the world it might be. And just kind of keep that in your head and see if you're right. But my PhD is about telling the stories that are locked up in these rocks. And to start telling you this story, we have to travel back in time, right? Geologists are earth historians, we're time travelers, and we're going to go back 70 million years, okay? That's how many zeros you need for 70 million years. And we're going to go back to a time, at that time, there were dinosaurs around, and they were just about to learn what a meteorite was, and unfortunately meet their demise. I'm sure they were, looking at rocks with their hand lenses at the same time. But at the same time as that, 70 million years ago, India, the country of India, the continent of India, was much further south than it currently is. It was below the equator, and there was a big ocean called the Tethys Ocean that was in between India and Eurasia. And at about 70 million years ago, India started a great journey, and it started to move northwards. And eventually this Tethys Ocean kind of closed up. And what happened was that India crashed into Eurasia to the north. It kept on moving northwards, and they crashed together. And that meant that all of the rocks that were at the bottom of that sea floor, all the rocks that were in the Tethys Ocean, they all kind of got stacked up on top of each other as they crashed into each other. And that is what formed wonder if you guessed it right, the Himalayas. That was a photo that I took in the Himalayas. This most fantabulous, one of my favorite words, mountain range. It's 3,000 kilometers worth of mountain. It goes all the way from Pakistan, all the way across through India and Nepal and Bhutan, back into India. This kind of phenomenal geographic and geological feature. And it formed because these continents collided together and all the rocks got forced upwards. So the Himalayas, also home of the adorable red panda, the Sherpa people, and of course Mount Everest, the tallest mountain on Earth, right? So Mount Everest is 8,848 meters tall. And did you know that at the top of Mount Everest, very top, at the peak of summit of the Earth, are made out of limestone, which is a rock that forms at the bottom of the sea floor. And it contains marine fossils. These are animals that were swimming around in the ocean, and now they're up at the roof of the Earth. I find that quite incredible. How on earth did they get up there from the bottom of the sea floor to 8,000 meters high? And that's kind of one of the questions that drives my research. I'm interested in how you make that mountain, how these rocks kind of reconfigure themselves and get moved all around to show us the mountains that we see today. And so to answer that question, this is kind of a broad question that I was trying to answer in my PhD, how to make a mountain. I had to go out there and visit the mountains, which was amazing. It's the most incredible thing I've ever done in my life. And I got to go to the country of Bhutan, which is out in the east of the Himalayas. And in my opinion, as well as being a beautiful country, it also has the most amazing flag in the world. So this is the flag of Bhutan. It's called the Land of the Thunder Dragon, and this is a thunder dragon that's on the Bhutanese flag, and I think it's wonderful. And it's quite a small country, but it's absolutely stunning. And I'm gonna kind of show off and show you some pretty pictures now, because I'm a photographer, so kind of a nice chance to show you all my pretty fieldwork snaps. And so this is what the mountains look like. So I spent 4 weeks in the mountains in Bhutan, taking samples, having a look at them, and being lucky enough to spend time in this fabulous landscape. So because of the mountains, it's quite rainy. So not every day was blue skies. We got quite a lot of rain showers as well. And these are the highest mountains that I saw. And I think the peaks of these, they're not quite as high as Everest. I think they're about 6,000 meters, around about that. And where we were working, the highest that we got up to was, 4,200 meters was the highest that I got up to. So high enough to start getting altitude sickness and start feeling that the air was thinner and that there wasn't as much oxygen around. And so we had to be careful when we were hiking around. And so we worked up in these high mountains, and then we also came down to lower elevations, which is what you can see in these photos in the bottom here, where we've got these kind of terraced fields where locals would grow rice and various different crops on these terraces. And this is one of the big rivers that you get that carves through the Himalayas and gives those mountains that really kind of the steep sides. Bhutan is a wonderful country culturally. So it's a Buddhist country, and it means that the architecture that you get there is stunning. So this is one of the monasteries, one of the main monasteries in Bhutan, and everything is kind of decked out in all these pretty colors. And you get these dragons and these wonderful kind of molds and stuff like that. You even get them on the this is a haulage truck. So this is just transporting goods across the country, and even that is bejeweled and colored and wonderful. And when we were there, they were making a lot of adjustments to the roads to make the roads bigger and safer for people. So this was a common view of ours, that we would be roads. Students go back and collect some more rocks. And when we were up in those high mountains, we had a whole team with us the entire time. But when we were up in those high mountains, we were hiking and trekking, and that meant that we needed horses to carry our stuff, and we had a guide and we had a cook. And I know that might make it sound glamorous, but it really wasn't. We were still in tents, but they looked after us wonderfully. And I think in the end they even cared about the rocks themselves. They were a bit unsure at the beginning, but I think we made them like them. These are some pictures of some kids that we met in one of the really remote villages. actually, this photo on the right here, I'm laughing because I have given this small child who can speak a little bit of English. I've given him my camera to have a play with and take some photos. So these are actually photos taken by this small child. And that was just a wonderful morning that we spent hanging out with these kids, and they loved our hiking poles and all of our equipment and stuff. And then, yeah, this was the team that we were out there with. And then when I was at lower elevations and we were just driving around, we had a different team, and they looked after us wonderfully well. The wildlife was incredible. And I know when you think of wildlife, you might not think of dogs, but in Bhutan, dogs aren't owned by an individual person. They're kind of looked after by the whole village. So you would get what we would probably call stray dogs everywhere, basically. And when we left our final village to go up into the mountains, this dog up here on the left, it knew that we had food, because anybody that goes along that road is going up into the mountains for weeks upon a time, which means that we have food. So he followed us, and he followed us for the entire 2 weeks that we were up in the mountains. And he was our little mascot, and we called him Adakite, which is a type of rock. And it was wonderful. We'd get back to camp, and he'd come bounding up to us, and it was a fabulous thing to have somebody else accompany us on this trip. And then, so kind of the more local wildlife, this is a black-capped langur that we found at the kind of just chilling on the side of the road one morning when we went out. We've got some macaques over here. This is a yak that was in one of the rivers that was up high in the mountains. Yaks are very common. Locals use yak milk and yak butter quite a lot. And then this image down here, hopefully you can kind of figure out what it is. That is a bear footprint. We did not know that there were bears in the area that we were working. We knew that there were bears in Bhutan, but they'd never been in the kind of elevations that we were working at. But as the villages are getting bigger and bigger, and there's more waste that's being put out by the villages, the bears are coming down to lower elevations. And so we didn't see the bear, but we did see its footprint. Which was quite scary, especially as we were on this track it was on our very last day that we were hiking out, and it was on this track, and we were like, the bear must have come along this track as well that we're walking along. But that was, yeah, my first ever bear footprint, which was incredible and scary, but cool. And then when I was doing my actual geology work, because I was there to work, unfortunately, it wasn't just all pretty pictures. This is kind of where I'd be hanging out and doing my work. So we'd be in river valleys that were full of boulders, or we'd be bushwhacking through all these trees and all this undergrowth. And yeah, I was hunting for rocks that were going to tell me something about how the Himalayas formed, right? And this is my supervisor who was out there with me as well. And yeah, we kind of track up these little riverbeds and stuff, or there'd be outcrops at the sides of the road. So as I said before, they were blasting and making new roads wider, which is great for a geologist because it means there's lots of fresh rock. And some of these places, I will have been the only geologist, certainly the first geologist to have ever seen these rocks before, which was quite a lot of responsibility. I had to make sure I got it right, and that I kind of did them justice. But yeah, this was what my everyday office looked like when I was out in Bhutan. And this is an example of one of the rocks that I was hunting for. So when I'm trying to figure out how to make a mountain, one of the really important processes that helps to make a mountain, to physically get those rocks up really high, you have to melt the rocks. So if you think about all these rocks that get stacked on top of each other, the rocks that are at the very bottom are under, tens of kilometers of other rock. And that means that they're under a lot of pressure and it gets really hot. So if you've ever scored the winning goal for your sports team and then everyone piles on top of you and you're stuck at the bottom, it gets quite uncomfortable and it gets all squashed, right? That's exactly what happens to the rocks. They get squashed under tens of kilometers worth of other rock, and they get hotter and it's really uncomfortable and they get squashed. And sometimes they can melt, and these so this is a rock called granite, and when that molten rock cools down, it forms this white rock called granite. And so that's what I was hunting for. I was up and down these river creeks trying to find evidence of this melting that could help me tell the story. Another really cool thing that I was focused on was, if you were in my No Time Like the Presentation talk the other day, you will know that my favorite mineral, and now your favorite mineral as well, is this wonderful blue mineral here called kyanite. And kyanite's great because it tells you that these rocks formed at the bottom of that big stack. They only form when you've got really high pressures. So when I saw one of these beautiful blue minerals, that would tell me that this rock formed at the very bottom of that big pile of rocks. And that was super useful. And the other cool thing about kyanite is that people know that it exists, but they kind of think it's a bit boring and it doesn't really have an interesting story to tell. And the main thing about these minerals, these individual kind of building blocks that make up rocks, is that they're really diaries. They tell you, they're the ones that are writing down the information about what's happening around them as they grow throughout their lifetime. And so I had to come up with an interesting way to try and, get a story out of this really boring mineral that people thought it was. And the way that I did that was with lasers, obviously. So I would take samples of these rocks, and then I got them shipped back all the way to the UK, and that took about 3 months for me to get my rocks back. And then I chopped them up into little slices so that we could look at them under the microscope and shine light through them and look at the individual minerals. And then what I did is I put it in this machine here. So this is called a laser ablation inductively coupled plasma mass spectrometer. Fancy way of saying you shoot a laser at a rock, it makes a hole in it, and that's what these holes are over here on this image. And it's all that material that was the mineral gets spat out into a mass spectrometer, and that can tell you the chemistry of the mineral. So it tells you the amount of silicon, the amount of aluminium, the amount of all of these different elements that are in your mineral, and that's how you get to the diaries. That's where that information is recorded. It's recorded in the chemistry of the individual minerals. And so that's what I did. So this is an image of all these little holes. Each one of those is about half the width of a human hair, and that's where I've shot a laser at each of those minerals to get that geochemical information out of it. And one of the cool things that I did is, as well as just doing spots, I did even smaller ones, and I did them all over an individual mineral, which people have done before, but no one's ever done that for kyanite. And hopefully this little video will show you what I did. So that's the laser going zzz, zzz, across an individual grain. And you do that, and you make lots of different spots, and I think it'll go back to that side, and then you get all these fuzzy lines on the computer, and then it's my job to figure out what those fuzzy lines mean, and each of those lines tells you how much of a given element is in that mineral, and that allows you to build up a map of where these elements are in a kyanite grain. And so that's what I did, and I'm the first person to have ever done this for a kyanite, which I think is pretty cool. And I make an image like this, and this basically shows where chromium is in a kyanite crystal. Now, we knew that kyanite could take in a little bit of chromium, but we didn't know that it would vary over a grain. So when a grain grows, it kind of grows like tree rings. So it'll start in the middle and it'll get bigger and bigger. And here you can see that in the middle, we've got a little bit of chromium, but then the next ring, we suddenly have no chromium. And then on the outside, we have loads of chromium. And so I'm the first person to have got an image like that. So a lot of my PhD has been trying to figure out what that tells me and what part of the story of the whole of the Himalayas this kyanite grain is showing me, which I think is pretty cool. I'm not sure I've quite nailed down exactly what it is, but I think it's pretty cool. And so, yeah, I think that's kind of a good overview of the work that I've done, what I'm interested in, and now I would love to hear some questions that you've got about rocks.
Awesome. We've already got some, so
brilliant.
Get ready. Here we go. All right. So our first question is: if there's a forest fire, do rocks ever melt?
I'm guessing no. So I don't know how hot forest fires get, but normally to melt a rock, you need it to be at least 600 degrees, I'd say. So there's various different melting points of rocks. So it's not like a piece of ice where you know that it melts at a certain temperature. It depends on the chemistry of that rock. So yeah, you definitely be looking anywhere from 600 degrees up to kind of 1200 degrees to get a rock melting. Yeah.
Sounds good. The next question's from Gavin. We know that rocks and minerals don't have DNA because they're not alive. How do rocks know what color hardness they should be if they don't have DNA?
Oh, okay. So I guess that it's all down to the chemistry. Again, everything that's kind of the answer to a lot of things, right? In science, it's all down to the chemistry. So there's certain elements that will like to stick together. Silicon and oxygen really like each other. And a lot of the minerals that you'll find in rocks are made primarily of silicon and oxygen bonds. So yeah, it's a combination of how exactly that mineral forms. And there's lots of very complicated kind of crystal physics and stuff. But yeah, we don't know a lot of, so when I gave the example of the kyanite, we don't know a lot about how that grows. And yeah, we didn't know that it could, take in those various different elements. And some elements, it'll be like, yeah, if that's there, I'll have a little bit of it. Others are like, no, I do not want that element at all. Someone else can take care of that, right? So you've actually got to look at lots of different minerals to see what elements everyone's taking in to really fill out that picture.
Very cool, thanks. How's lava made?
How is lava made? Oh, so lava is when you get molten rock at the surface, right? So when you get volcanoes going off and you get all that molten rock, it comes out of the surface, that's lava. If it's still under the earth, that's called magma. And yeah, life starts off as magma. When a rock gets heated up and it melts. And there's various different ways that you can do this. And actually melting in a mountain range is quite hard. It's quite a hard process for rocks to go through. A really easy way to do that is if you think of tectonic plates, and you have two tectonic plates that are moving away from one another, in the core, well, not quite the core of the earth, but on the inside of the earth, there's lots of hot molten rock. So if you move the tectonic plates away from one another, all that hot rock will come up to the surface. And if it makes it to the surface, that's when it's lava. So if you think about the mid-Atlantic ridge, so if you ever go on Google Earth, you might see this little kind of chain of mountains that goes down the Atlantic. That's what's happening there. These are volcanoes where that lava and that magma is coming up to the surface because the plates are moving away from one another. There's a couple of different ways that you can make it as well. But yeah, it's mainly to do with temperature. Yeah.
Cool. Awesome. All right, next question. How are fossils and rocks made?
That is a question that I have always asked. I do not understand fossils and how they are preserved. I don't understand how rocks at the very top of Everest can be made out of marine fossils. You need quite special circumstances to get fossils. So a lot of the time, so they'll form in sediments, right? So if you have a river that's breaking down rocks and releasing all that sand and material into the ocean, all that mud, often an animal will die, and then all that sediment will accumulate on top of it. And then if you've got the right conditions, so if you've not got other animals that might eat that dead body, for example, if you've got the right chemistry again, then it can be preserved. And there's various different processes about how you can kind of get different minerals will replace that material that's there. And it's easier to make a fossil of something that's hard than something that's soft, because you've got that hard stuff that you'll preserve, right? It's easier to preserve a bone than it is to preserve a jellyfish, for example. So yeah, it is a bit of a crazy process that I don't entirely understand how it works, but it does apparently. So
awesome. The next question from Teddy and Amelia: what's the smallest mountain?
Ooh, the smallest mountain. Well, I mean, that's when we get into the terminology of what a mountain is, right? Because even saying what I'm going to flip that around and go and talk about the largest mountain because it's easier. You can talk about what the largest mountain is, and a lot of people would say Everest, because that's the highest above sea level. But if you think of the Hawaiian Islands, I think it's Mauna Loa, is actually the highest from the base of where the mountain starts. And then if you think about it from where the point of a mountain that's the highest away from the like center of the earth. That's a volcano that it's in South America somewhere. I think is it Chimborazo? Think so, but that's a different mountain that is further away from the center of the earth. So there's lots of different ways that you can kind of define what a mountain is. I don't know what the smallest one would be. Yeah.
Whatever, sure. Like the first little like above the mountain definition line is like, yeah, because this stuff is sort of like a continuum of sizes. So
exactly.
Cool. Yeah. Let's see. Gavin would like to know, why does it matter to know how much of each thing is in a mineral?
That's a really good question. That's a question I get asked a lot of the time. So that kind of goes back to when I mentioned that rocks and minerals and geology is important for everybody, because understanding how these minerals take in certain elements and how they give them away and how there's more of one element in one mineral than another, that's really important if we want to find where these minerals are, right? So like chromium is a really important element. We use it for all sorts of stuff. It's a really important metal. So if you were trying to find where chromium was in the world because we needed it for our modern society, you'd need to understand how these processes happen. And if you know that they happen in a place like the Himalayas, then you could look for other times in Earth history where there have been mountains like the Himalayas. So you could go to Canada, where there were these massive mountain ranges, but they're much older and they've been eroded down, so they're not as tall as the Himalayas are anymore. So everything kind of feeds into knowing where stuff is, and being able to understand these different processes is actually, super important for running our modern day society.
Awesome. Let's see. Is there any volcanism in the Himalayas?
No, there isn't. It's really, we'd say that the crust, so the outer bit of the Earth's surface is really thick there because we've squashed all this rock together. So it's quite hard to get some stuff coming up. I think, I'm sure there are arguments where some people would say that maybe there is a little bit of volcanism, but I'm going to say no.
Sounds good. Do we ever harm rocks?
Do we harm rocks? I'd like to hope not. I feel quite bad lasering a kyanite mineral. That seems like a pretty destructive way to get an answer. I hope that we don't. One thing that geologists have, we kind of have the geologist code, and when we're taking samples, so I'd go up to a rock and I'd look at it with my hand lens, and I'd look at it in the mountain, but I want to take a little sample of that so that I can do further work at it back in my lab, right? So I get my geology hammer and I whack a little bit off, but you've got to be careful not to take too much, right? Like, you can't take the whole mountain back with you for logistical reasons, but also you want to be able to preserve this wonderful landscape for everybody else. You want to allow the geologists to go back there and see those rocks as well. So there's kind of a geologist code that you only take what you need, and every sample that I took was about a fist size worth of rock. So I'd like to think that we don't harm rocks. Yeah.
Sounds good. Let's see. What is the difference between a rock and a mineral?
Great question. Excellent question. So I'm going to use an analogy here. So if we think about, if we compare rocks to words, okay? So the chemical elements, so things like aluminium and silicon and chromium, stuff like that, they are like a letter in a word, right? If you combine letters together, you make a word. So if you combine elements together, you make a mineral, right? If you combine words together, you make a sentence. If you combine minerals together, you make a rock. And that rock can be made of minerals that are all the same or lots of different ones. And that's kind of the easiest way that you can break it down. So yeah, a chemical element is a letter, a mineral is a word, and a rock is a sentence.
Awesome. Okay. That's a beautiful way of describing that. Great. Okay. Gavin would like to know, do mountains affect evolution of life?
Ooh, I guess they do, because it will affect, kind of weather patterns and different environments that you can have, and like Yeah, like things that can, animals that can exist at altitude and stuff, that's all dependent on the mountains. Yeah, and there's definitely people who look into that, especially in the Himalayas, to kind of, yeah, see how fossil records work and everything changes. But yeah, I'd say that those big mountain ranges and plate tectonics in general has a massive effect on evolution. Yeah.
Totally. And if you're interested in that kind of thing and like to read pop science books, there's a book really about history called The Invention of Nature. It's all about Alexander von Humboldt and his, like, you know,
Brilliant.
his life basically. But they go into a lot of like how we first started to understand like different animal life at different parts of the mountain.
Brilliant.
And it's just like a beautifully written book. But that's a side note. So let's see. When you were doing your field work, did you ever find fossils?
I didn't find any fossils, no, because the rocks that I was looking at, so we have geological maps. So actually I have some geological maps in the background, handily, where people go out and tell you about, they go out and figure out what the rocks are in different parts of the world, and then you give a rock type a different color, and then you mark that little color on your map, and you make a beautiful map like this. And the rocks that I was looking at were in a very special kind of package of rocks that we knew where they were. And as I said, the rocks that I was looking for were the ones that have been down to the very deepest part of the mountain range, right? So they've been through all sorts of changes in temperature and pressure, which means that if there were any fossils there, which there could have been, because these used to be marine sediments, if there were fossils in there, they'd have gone now. They've gone through, the minerals have gone through so many different changes that you wouldn't preserve a fossil there anymore. So no, I didn't see any in the rocks that I was looking at, unfortunately.
Cool. Emma would like to know, what colors can mountains be?
What colors can mountains be? I guess that, again, that entirely depends on what rock they're made out of, and that's about the chemistry that they're made of. So, yeah, you can get green mountains, you can get grey mountains, you can get white mountains, and they might look very different when you're, looking down an valley and you're saying, oh, well, that's just a bit of grey rock over there. But then you can, if you get up closer to it and you look at it in more detail, there'll be lots of different colours going on. And there's some fantastic mountains in the Alps in Europe where I've been on field trips. And thankfully, there's been lots of different types of rocks there. And so we could be sat on one of the valley sides and we could see all these different colours in the rocks over the mountain, and we'd be able to map that out and draw that out, and that would tell us something about the story of the mountain. So yeah, they can be all sorts of different colors. Yeah.
Awesome. Raphael would like to know, what is the most used rock or mineral? Let's assume that he means by humans, because I don't know, there's a lot of different ways that could be interpreted.
Yes. I'd probably have to go. So the most abundant mineral on the surface of the earth is a mineral called quartz. And one of the biggest, one of the key materials that the world is based on is sand. And sand is made up of quartz. So each one of those individual sand grains is a bit of quartz that has been through all sorts of different things. And the reason you get something, you might look at a sand and you see that all the grains are all exactly the same and they're all kind of the same kind of smoky white color. They're the minerals that are left over once you erode everything else. So these rocks could have started out at the top of the Himalayas, and then the rivers brought them down, and they broke up all the minerals physically, and they separated them out, and then some other minerals dissolved, and the ones that were left were the quartz grains. And so quartz is a really resistant, it's a really robust mineral. It's really hard to get rid of. Basically, the only way that you get rid of it, or you cycle it in the rock cycle, is that you can melt it again, and it can go into other different types of rocks. So yeah, I guess I'd probably say quartz for, yeah, both those reasons. Yeah.
Cool, sounds good. What's the strongest rock?
Ooh, the strongest rock. So one of the things that happens when you make a mountain and you look at those rocks that are buried really deep, So they've been under incredible amounts of pressure and stress and lots of rocks over the top of them. That means that the minerals are all kind of squashed together and they're held really tightly. And often when you get them up to the surface, they will retain that character. So they'll be all squashed together and they'll be really hard, and you have to use quite big hammers to get hold of them sometimes. Equally, those rocks, because they formed deep under the mountain, they're not very happy at being at the surface. So they can go through a lot of changes really quickly because they're not used to being where they are. So there's a lot of different factors that would say what the hardest rocks are, and there are definitely people who know the answer to that question better than I do. Granite is a pretty strong rock. You know, it's forged in the heart of mountain belts and it's got all these minerals that are stuck together. So yeah, granite, I'd say.
All right, awesome. Let's see. So we're going to ask one more audience question and then we have to wrap up because it's already been 40 minutes talking about rocks.
Brilliant.
Teddy and Amelia would like to know, what do you think is the most interesting mountain or your favorite mountain?
Ooh. So, I mean, I have to say the Himalayas, right? Like, I think, and they're really cool because they're really young, okay? So I say really young in geological time. They only formed, you know, they probably started hitting together about 50 million years ago, which is like nothing.
Yeah.
As I said, the rocks in Canada are really old. And because you see them when they're really young, you still get to see all of these features. So I think they're really cool. My favorite, let's go for what my favorite actual mountain is. There's a mountain in Edinburgh called Arthur's Seat, which is basically the exposed guts of a volcano. And it's magnificent and you can see it all over Edinburgh and the rocks are really cool. And I would love going and visiting Arthur's Seat. So I'm going to say that's my favorite mountain.
Awesome. That's great. Okay, so we always wrap up with the same two questions for everybody. The first being, what is something related to your area of expertise that you wish everybody in the world knew? And then the second question is, what is something that you wish everybody in the world knew about literally anything? It can be as silly or small or significant as you'd like.
Oh boy. Okay, so what do I want people to know? I think the difference between rocks and minerals, I think that's a really kind of fundamental thing that's a really easy thing to understand.
Great.
Yeah, let's go with that. And then the second question was
anything in the world that you want people to know. It can be as silly or significant as you'd like.
Let's stay on brand and say that kyanite is the best mineral in the world and everybody should be appreciative of it.
That's great. Okay, that's wonderful. Well, thank you so much for taking the time to answer our questions today. This was super cool. Thank you, Erin, for signing for us today. We always are just so glad you're here. And other than that, reminder, next week on Tuesday at noon Eastern, we're talking about elephants. And then on Friday, the 29th, at 1 p.m. Eastern, we're going to be talking about bugs and likely seeing some bugs. So I'm keeping my fingers crossed for bugs. And that's really it for right now. If you'd like, you can sign up to our newsletter. I will tweet that out from the Skype a Scientist account. Can you remind us of your Twitter handle?
Yeah, so I'm Stacy Phillips, SHTACY_Phillips. You can find me there, yeah.
Wonderful. And you can find Skype a Scientist on Twitter at Skype Scientist. You can find us on Instagram at Skype a Scientist. And of course, our website, skypeascientist.com. Please support our program. We really rely on everyone to pitch together to make this work. You can do that at paypal.me/SkypeAScientist or patreon.com/SkypeAScientist. Thank you all for being with us today, and we'll see you next week. Thanks, Erin and Stacy.
Bye. Thanks.